All right, we'll get started then. My name's Aldrin Piri, and I want to thank all of you for coming out this morning. I'm very honored and very happy to be here on behalf of the Apache NiFi community. The presentation is entitled Data that Scales and the Values of Starting Small. I'm going to do a quick little introspection in terms of where data comes from and how it becomes big data, right? When it's just a little glimmer in our eye on some source system, and we want to get it back home to do some neat and impressive things with it. A little biographical information about myself. I'm part of the PMC for Apache NiFi, and I've been working with the tool before it was open sourced, going on 7 years now. I'm a senior member of the technical staff at Hortonworks, and I work on the HDF engineering team. So I focus a lot on taking users' feedback, making the tool better, improving it, and then also working on new functionality, especially now with MiNiFi, which is the core of this talk that we're going to discuss today. As a brief agenda, we're going to do a quick primer on Apache NiFi. Who here has used Apache NiFi or seen it, familiar with it? Oh, awesome, very good. That question was a lot more awkward a couple of years ago, so we're doing pretty well then by that standpoint. We'll use that as kind of setting the stage for Apache MiNiFi, looking at how those principles of NiFi are getting extended out and how it fits in the agent model that MiNiFi seeks to provide in kind of a smaller footprint. We'll talk about the architecture that's going on with that. And we'll talk about how it fits in Apache NiFi, which is burgeoning into this ecosystem where we have more components that are being reused in a community effort to kind of satisfy a lot of needs and kind of take us to that next level as a project. Finally, we'll conclude with a brief summary of the community, how you can get involved, list complaints, list compliments, whatever it is, and get help to kind of get better immersed in the technology. I want to kind of first start this talk off by scoping what we're talking about, right? We have our nice little table of SI prefixes, right? Always bytes after this. And as we kind of make our way down, we have varying degrees of big data-ness, right? All of these are Greek for something. We're going to operate mostly under the purview of the first few, right? Looking at the things that have no prefix, the kilobytes, the megabytes, right? All this small data that when aggregated and have stuff derived from it and built upon it, we get much larger data, right? It doesn't all start as exabyte and petabyte data at these sources. It all starts as very small things that kind of trickle in across many, many sources and taken on an aggregate, form a very large corpus of information to look at. NiFi itself is dealing with plumbing pretty much. So I have these sources. This is referred to as the anything and everything. These are these things that are connected through networks, through the internet, to various endpoints. And what they are is, innumerable, looking at everything from your cell phone to your watches, toasters, ovens, microwaves, you name it. They're all these smart appliances that have some connectivity, that are generating data and give us additional context about our world around us. And so they have this nice little pipe here that feeds to some back-end system. In the most simple case, right? And we do neat things with it. We put it through very impressive processing frameworks, Spark, Storm, Flink, all these great things that can do very neat stuff, right? And it's all about driving that value and getting those insights and generating models and reference sets so I can do more impressive things with it. But this is very nuanced. It gets very difficult to kind of understand and reason about how all this works. As a state of the art, we've gotten very good about generating data, firing it off someplace. And then we've also gotten very good at kind of processing that data. But usually it's a pretty big jumbled mess in between. There's a lot of moving parts. Data sometimes doesn't make it. There's a lot of harsh realities when we kind of leave the cozy confines of the data center. So to kind of frame this a little bit more, I like to use this use case of a courier service. And so you can think of it as kind of a few different tiers. At the core, you have your core data center at your headquarters. That's where the heavy duty stuff's going to. These might be, 1 to 3, depends on your geographic footprint. Branching out a little bit farther, you might have a regional site. In the case of the courier service, these are distribution centers, right? When I ship a package, put a parcel in the mail, there's these various regional sites that kind of aggregate these things, route them where they need to go to, stamp some additional metadata on them, note that they've been here, and then send them on to the next location. This then goes out to the fringes, right? And this is kind of where data is onboarded in the case of creating new things. It's also where these physical, tangible packages are onboarded at these physical stores. So I think of the devices that are there. I have these mobile devices that are scanning these packages when I register them. The registers themselves that take note of the transactions, send this information out. In the real world, outside the brick and mortar store, we have trucks, we have delivery men that are going out, handing off packages, and again, another source of data generation. And each of these are generating events too, right? We have metadata about what's going on. Think about the typical package you received when you bought that neat new tech toy and you're waiting for it to come in the mail. You're refreshing every 5 seconds. So, is it out for delivery yet? Is it out for delivery yet? All this is metadata that kind of stamps the history of where this package has been. And we find that when we kind of apply this to data, it's a very similar model that we go through. So typical deployment, when we first kind of brought NiFi out, has certain kind of a setup like this. We have NiFi in a kind of smaller form at a regional site. It fed the larger headquarters cluster, and then that fed the backend systems, right? It was kind of this tiered approach. Depending on footprint and resources that are available at some of these stores, a NiFi might sit there. Otherwise, a NiFi might sit at the regional place and then just listen for data that's fired off to it. This is pretty nice. It gave us a nice little tool to kind of make use of better managing our data flow and understanding how it's transiting about. And so from this, there's some key principles and design factors that went into the features behind NiFi. Guaranteed delivery is important. Where this came from, making sure that data was always delivered and got there was of the utmost importance. Everything was very important, and missing some pieces along the way was just not acceptable. Data buffering is a big issue too. Sometimes we don't have the reliability of a nice connection. Think of the case where the truck's out delivering packages and I'd like to send information back. I might be in a dead spot for my mobile service or something like that. And so it's important then for me to have a configurable buffer. But at the same time, it's also important for me to understand what that bounded buffer is. I don't want to keep accumulating data to the point where my device no longer functions or my system comes down. And so that takes the form of back pressure and pressure release, effectively letting some of that pressure off from the system and also exerting pressure back upstream to the producers of the data. There's also the notion of not all data being equal, right? Some data is more important to me. There's always this romanticized notion about I want all the data right now, right away. And that kind of works when we have almost unlimited resources available to us. But realistically, these smaller compute devices, people's phones, where cost comes a factor, we can't have all of it. And so sometimes there's a very specific timestamp on data that affects how long it's valid to me. At a certain point of time, it's perishable. I might not need it anymore. Whereas other things may come through that signal a certain event. Maybe in the case of a car, I notice a sensor goes off that an airbag's deployed. Well, that's a little more important to me than just finding out the latest song the person's playing on their infotainment system. So it's important to kind of take care of this and understand the quality of service and the latency needs of the data that's coming off a given device and system. Data provenance is this neat idea that I was trying to lay the groundwork for, talking about the metadata that's coming through for packages. It's a very similar notion, understanding the path that data took from the point it was generated to where it was consumed. I'll have a few slides a little bit later that go into this a little bit more so, but it's a very kind of key factor. Not only is your data important, but the path it took here and the values associated with that also tell a nice story. We have some other nice things too, from the UI perspective, command control, using templates to have reusable components and sharing across organizations. Security is of the utmost importance. Extensibility. We can make as many widgets and doodads as we want to bring data into a system and ship it with a given product. But at the end of the day, every organization has their slightly own way of doing things. It's not necessarily proprietary, but it's just the way it's always been done. So we need to be adaptable to those items as well. And of course, to support our large big data use cases, clustering is also important to get more physical resources available. I'm gonna go through this slide pretty quickly. We can look at these slides later when they're posted, but I just wanna highlight a few of the quick terms I'm gonna talk about. Flow file is the first one. You can think of these as the events or messages that go through NiFi and MiNiFi. I'll talk a little bit more about what the structure is on the next slide. The kind of core base of processing is this notion of processors and connections. And so when you take processors and connect them together, you get this directed graph of processing. These are kind of black boxes that are very functional in nature. I have data that comes in, I apply some function to it, something happens on the other side, whether that's routing, a transformation, or even something a little more complex like invoking a remote service or something like that. The flow controller is the item that kind of oversees and orchestrates all this, handles resource orchestration within the flow, and gives resources and tasking out to different processors as they execute. The best way to reason about flow files is a lot like HTTP data. We have a set of headers and then a content. So HTTP data, I might find out what the status code was, a timestamp that's associated with it, content type, and similar. Well, flow file 2 has similar things, right? I want to know what kind of content type it is. I might find out how long it's been in my flow, what time its lineage started when it entered the graph. And I have a binary content here. The key thing to call out is that NiFi does not really care about what that data is. Everyone likes to say that, hey, my framework's agnostic, and NiFi is too, But there's also the key understanding that ultimately users do really care about that data, that data has certain importance to them. There's certain schemas and stuff that are imparted upon them that they need to act upon and do things with. And so one of the nice things I like to think about of how NiFi is designed is the robustness principle. Be conservative in what you do, be liberal in what you accept from others. We don't always have the benefit of having perfectly curated data when it's coming into our system. So let's give people the tools to take that data that may be a mess and make a gem out of it and get it in the right format, at the right velocity, to the systems that need it and the consumers that need it. A good example here is one of the XKCDs for anyone that reads around, talking about date formats, right? Very real case, if I'm putting in various time storage systems or putting in Elasticsearch, how those timestamps are formatted usually vary a little bit. So massaging that so I can get to the right system is something that's nice to have a central kind of place to take care of and feed the consumers so they can just enjoy their data and get on to their more fun and interesting things to do with it. For those of you that aren't familiar with NiFi, here's a quick slide that just shows what this looks like. So I've talked about these processors here that are connected together with these black lines of connections. I have this process graph that's going on here. Directed in manner, you can see on some of these queues here, there's files queued up. These are these flow files that I mentioned before, these events that are going through the system. And the queuing shows that as processing goes on, if it's due to a certain processor taking longer because it's a more intensive task, or if it's because of back pressure exerting something back on it, these queue up, right? It's that bounded buffer, and I can configure how big that is, whether by objects or by sheer volume of size. So with that kind of visual model, and then that kind of background, it's at this point I'd like to introduce what MiNiFi is trying to accomplish. And the best way I like to kind of sum this up is, let me get the key parts of NiFi close to where data begins and handle bidirectional data transfer. Both data coming back to headquarters through whatever hops it may need, and also the results of what I've distilled down on the analytics side, whether it's a reference data set or models I'm going to apply to data, additional context and commands for things that come out there. NiFi is kind of a first-class process on the system. Give it a server or servers in the cluster, and it'll consume all those resources and can be tuned to get a lot of bang for the buck out of a given server. MiNiFi is usually a guest, right? It's a good steward on the system. It's not the star of the show. It's kind of in the background, it's an agent process, getting some information off of there. Depending on what you're accomplishing, how many resources are available, maybe the amount of work it does is a little more interesting. Maybe it does some edge processing to format that data down to conserve on bandwidth if I'm dealing with like a mobile case. And so with that kind of notion of where MiNiFi lives, thinking back to our architectural diagram we have, the courier service, there's some harsh realities of what we deal with outside of that data center, right? When we're being a guest on these mobile devices that move around or sensors or what have you. Limited computing power is one of them. Dealing with restricted software based on the environment it's living in. Again, we're a guest on that system. We don't have a UI, so we need a way to kind of interact with this in a way that makes sense, is repeatable, and is friendly for our operations folks. Sometimes these devices may get set up, deployed, and then no longer accessible for long portions of time. Think of the kind of use case of sensory and telematics being done on some remote oil rigs that only have maintenance efforts every so many months. They're not frequently updated, so as I have processing changes evolve and go out, there may be a wide swath of types of data that's going through, and they may have gone through different life cycles. So understanding how it came to be and where we're at becomes very important. Of course, security and privacy are big ones. You've seen about a lot of the denial of service attacks that have cropped up over the past couple months. A device or instance that is not properly secured becomes a weapon for hackers and the like to make use of and do some, quite frankly, very nasty things with it. So security is kind of top of mind, making sure that both the operational security as well as the transmission security is very well in tow. So drawing from NiFi, some of the key things that kind of gave way to MiNiFi and built it up to what it is now is a couple of the key features that were in there. One of them is site-to-site in NiFi. And so the best way this can be described is a kind of custom protocol for NiFi that takes care of talking between NiFi instances across network gaps. So you get very similar semantics as if you were in the flow. So I have a processor talking to another processor in that one flow controller on a given physical device. I want that to talk to another system. Site-to-site tries to bridge that gap. It has nice things like guaranteed delivery, and it's also great for handling scalability, load balancing to a cluster, and things like that, failover. It is very nice for those cases where I have an older system that isn't inherently cluster friendly. Some things that are socket-based, if I'm talking about SFTP and things like that, don't scale out to a cluster. So if I want to pull a bunch of files off an SFTP server and then fan them out to a lot of other different instances, this becomes difficult, and the protocol itself isn't necessarily there. So this becomes a nice stopgap to kind of help that, and then also make it more cluster friendly so I can do processing in parallel more easily. Part of the way this originally was done, so the kind of genesis of this was, we had those effectively agents too that were processes that fired things off, and then we had another process on the other side of NiFi that listened to this stuff and pulled it in. And so it was kind of searching for that next better way, right? Because there's kind of that gap in between where some of the semantics about how data is sent off and if it arrived or not got tough. So a site-to-site came up as the protocol, which did a handshake to ensure that guaranteed delivery. At some point, a member of our community then extracted this out to a client library. And this is actually what powers a lot of integration with some of the processing frameworks. It's establishing this kind of machine-to-machine format and interface between these items. And so we have connectors for Storm, Flink, Spark, Apex that make use of this site-to-site client library that let us send and receive data from those processing frameworks. And so it made a very nice model, kind of taking that notion and then applying it out larger, right? Because ultimately, I want to talk NiFi. I want to have things that have the full set of data and attributes when they're created. And then I want to be able to ensure that gets delivered to my target system. I want that format to kind of be intelligible, that when I receive it in NiFi, I can start doing things with it. So if I do some processing now and have a certain set of attributes that are going to affect routing downstream, I can ensure those get transferred in the same manner to NiFi when it reaches there. The next precedent from NiFi that kind of shaped what MiNiFi is was, again, this notion of provenance. And so provenance is this fine-grained event-level detail of things that happen with the flow files as they go through their flow. There's a whole series of different types of provenance types, a create, receive, and this kind of dictates the particular events that touch your data as they make their way through the system. So at a given point in time, I'll capture those metadata, those attributes I showed in the header section of the flow file, and then kind of snapshot those as well as the particular event that went with it. And so it makes a very compelling set of metadata. There's a lot of good information in there that kind of can be teased apart and look at how long it takes for certain things to process. It gives us nice insights into our operational process. Is this particular thing being used at some point in the system? Or no, or does it get dropped off someplace? So I can kind of trace through and see what's happening there and kind of value my resources at a very high level to see the full path of things. It also gives us the sheer veracity of data. I've seen a lot of times people get data that is originating on systems that may be poorly managed, or it's a legacy system, and they're not really sure what happens there, so they rely on network lookups for data once it lands in place, and then try and recreate that process instead of trying to tag things up front. I'm an advocate for kind of amortizing that cost. Instead of me making very intelligent guesses after I've received the data, let me just be absolutely sure and tag it at the get-go. I know exactly what this system is when the data is created, so let me be very sure and send that across so I can do smart things with it. To kind of visualize this out, here's a certain provenance chain that we'd see here. In this case, I have a particular event that was received. In this case, I can see that came across HTTP in this scenario. I have a UUID that's here, a certain component that touched it. And then I can navigate through and look at the individual components that went through it. So I'll see I went through a series of attributes modified, and then did a content modified at some point along the way too. And so it gives a nice kind of trail of things that happened there. With this menu, I can also then look at the attributes that were associated with it, how they changed. I can dive in a little bit deeper and then look at the content that's associated with it. And so part of the thrust for MiNiFi is I have this really nice map of events in NiFi. And people really like that. It's nice to see how things are behaving. But the next question is, well, what about this stuff when the things arrive at my doorstep? Where has it been before that? And part of MiNiFi effort is to kind of branch out and illuminate that map a little bit more. Let me go very close, or as close as possible as I can, to where the data is created and completely understand the full path of all of this. Let me send those events to some store so I can analyze the full process and join these things together. Look at the full graph of the metadata, which is very compelling, especially if I look at how it's then delivered to systems and how it's used by those systems for analytics. There are customers and organizations that will use data and pay very large sums of money for reference data sets. But how do they have true fidelity in understanding how they're actually being used? Am I spending a lot of money and getting very little value for my business? Or is this open source equivalent data set maybe 90% effective, but 100% free? These are some of the things that we can use metadata from the provenance events to kind of help guide our organization and shape our processes. So there are some departures from NiFi, and that's all about kind of going to the smaller footprint. The feedback loop is a lot longer. So in NiFi, if I have changes going on, that flow you see there is interactive. If I want to make changes and fork data off to a different path, I can do that in real time. And data will make its different path there and go down a separate line of processing. In the MiNiFi case, I have, again, remote instances that are out there. And so I don't necessarily have the luxury of knowing exactly what it's doing at this exact time. So we wanted to have a way of kind of declarative processing set up, something that's CM friendly. So if you think of your puppets, your Ansibles, and things like that, as a first stop to kind of make this happen. To your right here, you'll see a sample config file. This is pretty verbose. We have some tooling that helps use NiFi as a designer in its current state that you can then export and then provide to a MiNiFi instance. The interface that reads in this YAML file is extensible. So while YAML was the first one we chose because it's doable by hand if you want those kind of simple cases of I'm tailing a log file or I'm looking at a directory and sending those files or those lines across a given network connection. In this case, site to site is a preferred choice. I can do that by hand fairly easily, but if I do more complex processing and things like that, the UI becomes very nice. And so we have tooling that, again, I can create a template, export that template through NiFi, and then run a conversion on it that makes it suitable for MiNiFi itself to run. As part of that footprint, we also reduced a set of bundled components that come with things. The NiFi release in its last form was about 800 megabytes. A lot of that's because of custom extensions and those libraries that come with it, which are really great because you can do so much with it out of the box. But we don't always need to talk directly to HBase from a MiNiFi instance or something like that. For the Java instance, fear not, it's API compatible with NiFi. So if there's an extension you want, if you do have a case where you need to talk to HBase from that MiNiFi instance, you can drop that NAR package that's in there into a MiNiFi instance and make use of the processor like you would in NiFi as well. So I'm kind of scoping where we're headed with this and what we're doing with it. There's kind of three sizes that we're going here, right? Furthering on our hike up the table of big data. Going small is Java. As I said, that's making use of a lot of the core work and a lot of the time and battle-tested functionality that's in NiFi. It has feature parity with that framework, and those processors will work for the same version that's with it. We get the nice write once, run anywhere. Anywhere is kind of asterisk and start off because, well, not everything is amenable to a JVM, or sometimes costs in certain devices for certain licenses can be prohibitively expensive, especially when you're thinking about those IoT cases. We go a step smaller then, go smaller, C++, write once with a lot of clever planning and well-designed. I can build that anywhere. And most devices that are on there can run C++. So it gives us a very nice deployable footprint. But this is an effort that started from scratch. So while NiFi is entering its 7th or 8th year of development and being run, C++ is starting from much earlier. So we're starting with the core framework and then building up from there to provide the same components and functionality that we'd expect. Going smaller than that, sometimes we don't have the luxury of running a process. Think of mobile cases. I want to make a library, an SDK that makes it very feasible for people to get the nice functionality of provenance, tagging, that type of stuff, to do telemetry off of phones or telematics units. And so my friend Zoodlander says, what is this? A NiFi for ants? Not quite ants, but we're going smaller, right? So one of the cases that comes up and is very popular to talk about is that of the connected car. Thinking of OBD2 type level of interaction, For those that aren't familiar with cars, there's a whole lot of fast-moving data that exists behind this thing called a firewall, which is effectively like a network firewall, but for the car and its kind of key components that are driving the drivetrain, things like that. And there's things that sit on the outside of it that have a diode that effectively allows some of that data to come out that they can make use of, things like GPS and things like that. And so we'd sit there on this smaller thing. Hardware-wise, it's underpowered phone in a lot of cases, but can vary. But think about this, talking about that idea of doing processing, this edge processing on MiNiFi in a smaller constrained environment. Before, cars would have some library that people would write a script for, and then send the data off to some endpoint, right? And so that kind of sits up there, and there's no real idea about where it came from, right? Here's this data that's exposed to me. I don't really have much insight into where it came from beyond that point. Instead, our model is to opt for listening to those interfaces that are available to us. And at that point, we start the provenance trail. So I know what network it came from. There's a series of networks in the cars. I can tell what device it was and tag it from the get-go. The utmost fidelity in terms of where it came from, short of getting the other side of the firewall, which varies, obviously, depending on the processing power that's enabled there. And so this is about going from one extreme to the end, and then understanding the full path along the way. That's a nice kind of high-level view of this and the relationship between MiNiFi and NiFi. You can see MiNiFi starts on the left here, and NiFi sits to the right. And depending on what your footprints look like at different tiers of your architecture, each could sit at different points along the way. At the regional data center, if it's a place where it might be lower volume, maybe a MiNiFi instance makes sense. Maybe I don't need that configurability. But maybe in some cases I do, so a NiFi sits there. The key thing that happens, though, is that we're using provenance as our way of kind of looking at how data traverses our system. That's our kind of first currency of things that are going through there. And the second thing is that notion of site-to-site, a protocol that all the things in the NiFi ecosystem are coming to adopt and use, and then we're making it extensible as well. Originally started as a raw socket. It recently got enabled to do HTTP to enable those proxy situations to minimize security footprint. And there's been talk in the community of also extending it out to fit a lot of your kind of constrained protocols. Think of CoAP, MQTT, things of that, and mapping the semantics of those protocols to the site-to-site ones as they see fit. So jumping back to our courier service that we talked about before and fleshing this bit out now that we've learned about MiNiFi, maybe this changes a little bit. Maybe on our mobile devices and our registers, places where we can't run a process, but people want to get into NiFi, we have client libraries that help with that kind of exfil of information off those systems. The trucks, MiNiFi runs extremely well on the Raspberry Pi type device. That's very quite powerful and frankly is ridiculously fast computer for how cheap they are. So that's not saying a whole lot. We can go smaller than that too, but it's just kind of scoping. A little device like this, a little box like that can sit on these devices and these trucks as they go through and beacon home with various information. Again, taking all those principles of NiFi that we talked about, buffering, guaranteed delivery through site to site, pressure release, back pressure, this configuration and deployment of flows, and then doing some processing to trim data down because I don't want to send bulky information back across my expensive mobile connection. Choosing what network interface it goes across. A lot of cars nowadays have Wi-Fi modems in them as well as LTE modems. Some stuff I care about right now. Like I said, if that airbag case happens, or there's a big accelerator change from I'm going this fast to a negative acceleration really fast. These are things I care about. I want to know about those now. But there are things about, this is the last time I did my diagnostic test and everything was okay. I can take a little bit longer on those, and that's fine. So MiNiFi can serve as this way of getting that data, a higher quality of data, and then kind of seamlessly feeding into these NiFi clusters that can then work against certain attributes and understand what is there to handle the routing that's going on. No guessing has to happen in these processing frameworks under this model. I can just do things I care about, like doing the really neat aggregation and windowing and understanding how that data looks and going real deep instead of trying to do cleanup. Using that same slide and overlaying the data provenance lens on it, here are some of the kind of key features we're looking at, right? Looking at origin, the attribution of things through those tags, a replay of events. There's a buffer that's configurable for NiFi on how many events are held content-wise. Make requests to those things out if I didn't get something, or I'd like something played through again because I've changed my upstream. Things like that are very nice. On the back-end side, I can see how the topology changes, right? I've introduced a new processor into my flow, and I've noticed I've had hit to performance? What processors are causing this? Let me tease through the provenance to understand what parts are problematic, and then seek to correct those or add more hardware as needed to support those cases. So we've kind of provided a nice framework to extend the reach of this data, right? If we're looking at provenance as what we really care about and what we're going after, we're extending the reach and lighting up the map a little bit more. So we had the map pretty well lit up from NiFi in that kind of central area of your regional and core data centers. And now I'm pushing out to the edge a little bit more. I'm illuminating the path from very close to where the data is created. So that's all great, and that's working pretty well. I've had this nice machine-to-machine interface for site-to-site. The data, when it arrives, is just like any other data that comes into the system, whether it's another pulling off a Kafka cluster or a JMS topic, or they've been MiNiFi instances that are putting things across site to site. There's really no difference in NiFi. And then we had the same extensibility for Java and C++ as we did for NiFi. Again, dealing with realities, those kind of soft factors of integration, where your organization, even though they use open standards, they have their slightly own way of doing things. Whether that's for proprietary reasons or not, there's just a certain way we conduct business, and this aids in that process. And then finally, the reduced footprint that allows NiFi functionality to kind of make it out farther, depending on the hardware that's available, whether it's Java or C++. So the next question then is, oh, these instances, they make things more operationally complex for me. I have a huge fleet of trucks in my courier service. How am I supposed to get all that data together, and how am I supposed to manage these things? And that's what we're working on addressing now. There's some preliminary functionality in our repository, and it's a big focus area of focus for us right now, excuse me. And that's this notion of MiNiFi command and control. This is all very notional, and we're kind of working through this. But the idea here is that I have this command and control API that allows me to have instances kind of phone home, find out what flow I should be running, find out what data sets are available for me. That C2 API is important because the realities of where these things live, the networks they live across, allows us to set up these different facades and proxies that I can get closer to where things are and traverse network boundaries where need be. So it acts as this kind of source that I can replicate and apply a bunch of different scenarios. In some cases, it may be a device that sits there and it's just doing processing and it's completely off network, but I want to pull things off of a disk at some point in time. This is kind of set up in that manner to try and help us accomplish those things and deal with all these real realities of networks and what it entails to get data off of all these different devices. The kind of core experience that we're going for is the same as NiFi. While NiFi is interactive command and control, the user experience is very great. I can drag processors onto a graph. It's very visual. People that are not programmers and not well-versed in juggling 5,000 different XML files can do very impactful things with NiFi. And so it gets very powerful. We want a similar manner of designing things for MiNiFi, but then also have a design deploy approach. Instead of having it happen right now, I choose to deploy it, and then based on the instances and their characterization, their groupings, I then push those flows out and get them to those instances, and then keep tracking of the flows, tag the data with a given version of the flow so I can realize that this guy's been on the network for a long time and it's pretty far behind. This data no longer means anything to me. This C2 effort is a great bit of functionality. It's very MiNiFi specific, but it's building on top of a lot of the great efforts that are going on in the community. We don't have a lot of time to go through all this, so I have some quick high-level notes here and then links to them that you can follow up afterwards. But there's three kind of big components that are coming. One of them is configuration management of flows and versioning. So think of improved SDLC stuff. Thinking of, I have a flow, I want to snapshot it, I want to maybe pass it up to production with a set of different variables. This works in conjunction with the variable registry, right? So I want the same flow that I run in dev to then be promoted to integration, talking to those integration systems, and then make its way up to production. And so those two work in concert to kind of help facilitate those processes. MiNiFi can just benefit from both of these things because those flows are version flows that I can then push down to my agents with a given set of variables for its conditions and its environment it lives in. Extension repositories are a nice way of publishing and sharing extension bundles, or NARs, right? Those components I'm dealing with. This allows us to ship out a kind of lightweight version of NiFi or MiNiFi, and then pull additional bundles in as I need to kind of create my own distribution. We've gone quite large, but it'd be nice to kind of let people tease out what they really care about. If I'm just doing, hardcore text wrangling and stuff like that, I may not need to go to Twitter and pull things down like that. So let me pick and choose. So kind of in summation, why Apache NiFi and MiNiFi? Moving data is kind of a multifaceted challenge, right? And there's a lot of different contexts in which we have to deal with things. There's a lot of realities there, kind of the soft factors that we have to deal with that are also challenges beyond sheer rates and volumes. Think of the Courier example in the organizations that have similar architectures and how we traverse those boundaries, especially when it gets put in the context of global and international business affairs where compliance and regulations vary. We want to provide common tooling. So, give them a core data set that they can do a lot of neat things, but then also allow them to extend for their own needs. And finally, one of the reasons I'm probably most passionate about the project in the community is that we enable a lot of folks managing infrastructure and people that aren't necessarily developers to have a very active part in your organization's data ingest and integration. I will avoid cliches about tech-savvy grandmas and grandpas, but anyone that has some decent working knowledge and a little time can sit down and do some very powerful things by connecting some processors and reading some of the docs. Here's some quick notes on NiFi and the community. Things here sound good. If you have more questions, please reach out to us on the mailing list. File JIRA issues if you're using us and things aren't so great. We love compliments, but we love issues and complaints even more because we know there's room to improve and it helps us get better. And it shows that people have a stake in things and are passionate about it. Two kind of self-serving things. If you want to learn more about NiFi, we'll do a deep dive more specifically in that and a little hands-on lab on using it. I'll be hosting a crash course tomorrow. That's first come, first serve. Ensure you have the latest VirtualBox installed on your system. And we'll go through a more deeper dive overview and demo of NiFi, and then also a lab. And then if you're not interested in going there, you can't get into the 50 slots that are available there. I'll also be one of the people hosting the Birds of a Feather session on IoT streaming and data flow tomorrow evening as well. Or if you're feeling really adventurous and you really like me a whole lot, do both of them, and I don't know, we'll be best friends for life. So that's all I have. Thank you so much for coming here, and on behalf of the Apache NiFi community, I hope you'll come out and join us. Might have a minute or two for a couple quick questions, if anyone has anything. Excellent. All right then, thank you very much.